you, Alvin. I guess most of you know Alvin quite well by now. He's a senior researcher in Xpress Internet Services, mobile phone SE&A, Microsoft Device Group, and currently at Microsoft. He previously worked in Nokia research, and he loves studying user behavior, especially at mobile web and also on social networks, mining big data for browser applications and so on. Without further ado, I invite Alvin to present his keynote talk entitled Connecting People Through Mobile Social Networks.
Okay, thank you, Theo. So everybody knows that Microsoft bought Nokia, right? So I'm not part of Microsoft, but a lot of this work was when I was with Nokia Research Center. So hence you can see the Nokia phones there. Okay. So mobile social networking. How many people have heard this term, mobile social networking? Show of hands. But actually, do you really know what it means? Because I think a lot of people out there, they misuse this term. They think mobile social networking is something where, I use a phone and I access Facebook or I access Twitter, okay? In my opinion, that's not mobile social networking. That's what we call social networking on mobile, because you're using the mobile to access a social network. What I mean here by mobile social networking is that how we actually can use the phone to actually really meet people. So this requires sensors, right? How do I know that I met Theo in this conference? How can we do that? So my class is going to talk about that. So mobile social networking is about providing an integrated experience by fusing physical and digital social interactions through the mobile. So we're trying to combine this offline part, which we can get the sensor from the phone, and the online part, which is through the cloud and through the social networks. So that's what we call mobile social networking. Okay? So what's the difference between social networking on mobile and mobile social networking? So this is what I put a table here to kind of explain what I think is the difference. So we look at the first one here, duration. What you're doing, for example, Facebook or Twitter on your mobile phone is continuous in the sense of that there's really no stop or end time. You just go ahead and you access this social network. But we talk about mobile social networking. This is offline. So when I actually meet you, we social network, but we just do it at the conference, and that's it. And then afterwards, then we go back to our universities or companies, right? So that's what we call ephemeral. It's something that's temporary. We create a social network for a temporary period of time at a specific location, at a particular event. So it's a temporal thing. So that's why I call it ephemeral. The second part, offline interaction. Okay, when you're doing social networking on mobile, you're just accessing space. You're just accessing this social network. You're not really interacting with people. So therefore, that's why with mobile social networking, it's activity-based, because we know based on your location and the context, let's say, stuff from the phone, we know what you're doing. We can actually infer your activity. And that leads to the third part, the proximity and location. So with social networking on mobile, we have GPS or so we know that, for example, you're located, let's say, in Tsinghua. If you use Foursquare, then you can, check in. But if you have mobile social networking, we can actually go deeper. We can actually see where you actually encountered someone. Whether you were nearby someone, because we have this peer-to-peer kind of interaction. And then for context, right, because we have sensors, so we can be able to sense the environment. For contact management, if I want to meet particular people, I can do it directly through mobile social networking because I have the phone to phone together. So I know that, for example, if I want to get your business card, I don't have to, directly give you my business card. The two of us can connect because we two are close to each other and we can exchange business cards. And then also the same thing for content sharing, because now that I know that we were together, I can create a group that's just only the people that work together with me, actually physically. Whereas if you have for Facebook or Twitter, you don't have that because everything is public. So therefore, this also can help to address privacy, because if everybody is connected together in a network physically, then only those people people that are here can only access the information. People from outside cannot be able to access because they didn't come to the conference, for example. And then for collaboration, because now we have peer-to-peer, then we have ad hoc connections. Okay, so this slide here shows that I believe here that we have this gap between offline and online. So we have our own offline networks, right? So at this conference, we meet people, right? So we've created our own social networks. But how many of those social networks then become online? So if they become online, it means, okay, for example, let's say with Kale, right? I have your business card. I didn't have to add you to my Facebook. I had to add you to a friend request. I have to follow you on Twitter. It's just very, very cumbersome. Okay, so how do we address this gap where if I directly meet Kale, I can automatically send a friend request to him on Facebook? But maybe there's many, many other people also named him as well. How do I know who is the right one to add? Okay, so that's the time so we're trying to address that. So, like I mentioned before, we have this social network that we create in this conference or a meeting or any other particular activity. And we call this an ephemeral social network because ephemeral means temporary, right? Things are temporary. So in this ephemeral social network, I call this, ACQ, as a mathematical equation, because when we're here in activity, which is this A here, there are 3 C's, right? During this activity, we meet people, so we have contacts. We have content, right? The content is this conference, it's the papers, it's the discussion, it's the paper stuff, the talks, the slides. That's your content. And what's the context? We're here right now in meeting room 1-312. So that's your context. So you combine all these 3 together, and we know that we are in this ephemeral social network. And if we create this ephemeral social network, we can then bridge from online to offline, actually vice versa. Because if you think about it, when you are on Facebook, how do you add people? You add people because you met people from somewhere, right? So you add them there. So all these networks that you create offline then can be transferred to online. So the whole idea here is that wouldn't it be cool that if I met all these particular people at a conference, meeting, party, or whatever, or hiking event, it can automatically synchronize directly to my Facebook or Twitter or Weibo or Renren or whatever type of social media. Then I don't have to worry about having to add friend requests or whatever, and I actually know why I want to add you because it knows that we actually met at some particular place. So I hope you kind of get this idea here of what we mean here by an ephemeral social network. So it's kind of like a micro social network, right? So when you see, if you look at the Facebook social network that you have, the graph, there are subsets, right? So there are subgraphs in this Facebook network is because you met from some particular event, right? So these are like those micro social networks. Okay, so we can use that in order to improve recommendations because now we have this context. Then I can say, for example, if I see someone of you add me on Facebook, now I know why I should add you on Facebook because I know that we 2 of us have met here at this conference. So now we have an additional reason why I want to add you as a friend. Because I'm sure a lot of you, I don't know about you, but for me, I get a lot of friend requests, and I have no idea, why I should add this person as a friend, right? We have limited amount of time. We already are already very busy. Why do I need to add you? Right? So what is this context? So this context, I think, is like this 4 W's here, right? So the what, why, where, when, and then the what, H, the how. So what is context? Context is social, right? We have these social interactions. So we have things that are in common, which in sociology we call it homophily. And we also have influence, how we influence each other people, how people influence us. We have local, so based on position, things are temporal, things are spatial. And we have mobile, because things are dynamic and things are ephemeral. So what I'm going to talk about today is talking about recommendations of people, that's the who part, places, the where part, and content, the what part. Okay, so the first I'm going to talk about is this, how we recommend people through proximity and homophily. So this was work done in the Nokia Research Center. So one of the questions we wanted to ask here in this project was that, I'm at this big conference, let's say, and so many people here. So maybe someone comes to me and says, oh, Alvin, how are you? Like, we met before. I'm like, well, where we met before? I don't remember. I have so many people that I'm meeting. So the first question is, how do I know you? And why I should add you? And have we met before? Right? These are questions I'm sure you have as well too, because we meet so many particular people. What's this context as to how I should add you, why I should add you? So what we did here, our contributions to our work here, is that we built a friend recommendation system that uses proximity. So we use the phones to be able to interact with other phones. And we actually use Wi-Fi to do this. Use Wi-Fi on the phone. And then we also added homophily, which is the common stuff. So what do we have in common? For example, do we attend the same, keynote speech right now? So this is something we have in common. And then we did a user study to actually show that how the recommendations are actually better when we add this proximity and homophily. So there's been a lot of research actually show that proximity can be an indicator of friendship. And actually this project is actually based upon some research from Intel research. So Intel, they have this project that was in 2002 called the Familiar Stranger. Anyone heard about this project? So no. So the whole idea here is that, let's say for example you're in Beijing and every day you come to work every day and you go on a subway, okay? So let's say you always go to the same car on a subway every day, and it's always the same person sitting at that same spot every day. So he's familiar because you see him every day, but he's a stranger because you never talk to him. So maybe perhaps there's something that he has that can help you. Maybe he's a professor or so who has some interesting research that maybe you can use. So we call that the familiar stranger. Because many times in a conference or in a meeting, we might bump into people or meet new people, but we don't know who they are, and perhaps they can be able to help us. So there are many opportunities that we miss to be able to add these particular people. So that's called opportunistic networking. And there's also some research to show that geography and friendship are correlated. So there was a Facebook study that showed that the user's probability of friendship is inversely proportional to their distance. So meaning that if you are closer to each other, you're probably most likely to be friends. And of course, there's a lot of applications that show that if you add people online, that they are also offline. So for example, WeChat, Foursquare, right? When you check in, it will tell you who are your friends that are nearby. So that's proximity. And we actually did a study too. So what happened is that in a conference, we gave people Nokia phones and with Wi-Fi, and we were able to actually see whether people encountered each other. And we wanted to see that, does the encounter really influence this adding as a friend online? And so what we did here is that this, you can see here, the 0 point is when we actually added a friend request. And before, we see that these particular pairs of people, this is like the average total number of encounters. So they encounter more often, and then they get to a point where, okay, they encounter a lot, and then they add each other as a friend. And after they add each other as a friend, then of course, then you want to meet each other more, so then you see it starts to go really, really fast. But then it gets to a point where it plateaus, because afterwards you probably want to meet other people in the conference. Right? So this kind of shows here that, if we encounter more particular people, this will influence the probability that you want to add that person as a friend. And homophily, so this what's the shared component, can also be an indicator of friendship. So we have, for example, shared content interactions. For example, why I add you as a friend? Because we're here together in the social com. We have something in common. We like social computing, social media. Also, same people, places, things, and things like that. So this is actually what we did. So we did this, actually deployed our system in a conference. And what happened is that we did it actually here in Tsinghua. This was actually in 2011 for UbiComp. So UbiComp, we had a conference here in Tsinghua. And in this case here, we didn't give people Nokia phones because obviously it would be a restriction. So we actually did a web app and we gave people RFID badges. So instead of what you have here, you actually have an RFID badge. And we put RFID access points in every room. So we could be able to determine if you were in this room and whether you actually met another particular person. So we actually built that system, and in here we actually show you all the people that became friends or contacts with. So this is the contacts graph. And then here, this actually shows here, it's very dense here, it's hard to see, but you can see here there's an encounter graph. So these are all the people that actually encountered each other during the conference through the RFID. So we can now use these two graphs in order to determine whether we should recommend this person as a friend or not. And how do we do that? So we do it like this. So this is our friend recommendation algorithm. So what we do here is that we have different features. So we have different weights. So we take into account if you have common interests with another person, if you have common friends, if you have encounters together, did you meet each other at a session? And if you also, and this is actually, if you had any question or answer. So if you had any Q&A together, then we also add that as well. And then we calculate the relevance, and we do this weighted average in order to determine the score. And then we recommend the top K users from the score as a list of friends, and then you can add those people as friends. Okay, so that was the algorithm. How does this actually work for the user? So let's look at the UI. So the UI is like this. So you have your phone, and you're in this conference, and you open this web app, and here it shows you, this is me, for example, and it shows you people that I've added as contacts. These are recommendations from our system. So it says your 10 people recommended to me. These are the 10 people. Why should I add them as a friend? I can see their profile and who they are. And then here, this is the important part. This is the homophily. What do we have in common? So what we have in common here is we have research interests, right? So what do we have in common? So everybody can specify in their profile what they're interested in. So this is very good because now you can be able to figure out who are the people that I should actually interact with, right? Because if you're in a big conference, who are the people that you should meet? Who are the people that you should actually collaborate with? So here, we actually now know who are the people that you should meet because we have the similar research interests. For example, RFID, context inference, and so on. And then the offline part here is the encounters. So we actually can tell you, okay, when was the last time that you encountered each other? Where, for example, A438, 4th floor, what time? So we actually can get that information. So now when I see this, Bin Chu, I'm like, oh yes, we met each other at what session? We met each other at the tutorial. Okay, great. Now I can add him as a friend. Okay, so this gives you now more kind of detail as to why you should add this person as a friend. And then after that, you can then send a message to a person to say, oh, okay, why I'm adding you as a friend. And then here we actually ask the people when they added a friend, why is it that you added this person as a friend? Because we wanted to actually see, why people add each other as a friend. Is it because of they encountered before, they had common contacts, common research interests, common sessions attended, knowing each other in real life, knowing each other before, or adding each other as a phone contact. So we wanted to kind of do a user study to compare why is it that people add each other? Is it actually offline? Because that's our hypothesis, right? We want to say that offline helps to add people as friends. So this is this online kind of survey that we did. And this is the actual experiments that we got as a result. So actually before we gave people this Find and Connect, that was the name of our system. So before we gave them our system, our application, we asked people beforehand, the same questions. Why do you add people as friends? The same questions. And then therefore we can compare again with our application. And if you see here, you can see here that the reason why people add each other as friends is because we know each other in real life and encountered before, right? So that means this is offline that helps to add each other as friends. And then we also did a study in the office, the Nokia office, where we gave also people the phones, and we tracked their location and their encounters, and we compared the two algorithms. So most recommendation algorithms use common friends, right? If you're a friend with someone else, then you add that person as a friend. So we have common friends here, and there's another algorithm we created based on whether you had encounters with that person and whether you met that person. And we calculate, for example, we ask you, is this a good recommendation? Do you know this person in real life? An example. And then we can see here that the higher percentage here is because of the encounter needs. So people add more as friends because of, they met each other and they encounter each other. So again, this also validates this offline helps to add people as friends. Okay, so that is the first part for this recommending people. The second part I'm going to talk about is recommending the people for the followers. So this is talking about the places. So this is called Who Will Follow Your Shop, exploiting multiple information sources in finding followers. So in this project here, what we wanted to do here is that we wanted to predict the hidden semantics of the shops. And we used heterogeneous sources from BIGDATA to handle this data sparsity and cold start. And we figured out the correlations between users and shops. And we used this real data called Gaussian. So let me tell you about Gaussian. So Gaussian is something that we created. Are you familiar with something like, what is it, Groupon? Right? Or Dianping in China. So this is a website that you can do like group shopping, or you can like get some deals, right? So we actually created an application as well where we also got deals from vendors, and people can go to particular places, and we can know based on their location, we can recommend particular places that they should go to, or their special deals. So for example, if you're in Beijing and I want to find a good Peking duck restaurant, I can open this app and it will tell me, hey, this restaurant here is quite good and there's a discount on this restaurant, so why don't you go? And then you can then get this coupon, go to the restaurant, show the coupon to them, and then get your discount. So this is offline to online phenomenon here. Okay, so in this project here, in this application, we actually recorded people's users, their GPS, and we also recorded all the clicks. So we know that what shops that they visited and if they bought a particular coupon and things like that. So we have this rich data. And from this rich data, we can be able to extract user behavior. So we can see here that we actually do this cosine similarity to determine if two users are similar or not. We use this matrix factorization. And then for the shops, how do we know that we should recommend a shop to you? We use TF-IDF because, for example, a lot of these shops, they don't have much information. They don't tell you that. So we actually use the web. So we use the web search engine in order to get some more information about these shops. And then to figure out shop-to-shop similarity, we do this IDF, and again we do cosine similarity. And then we use LDA because we want to get hidden topics. There's certain things that are not, let's say, on the website for the shop. So we want to get some additional stuff. So if you're familiar with, data mining, you're familiar with what LDA is. So LDA is used to extract these hidden topics. Okay, and then we created our algorithm here called intent-induced topic search. So this is an adaptation of the HITS algorithm. So everybody here heard about HITS? It was created by John Kleinberg. So the HITS algorithm is actually very popular because that's actually the basis for PageRank, for Google's PageRank. It's actually based on HITS algorithm. So we use the HITS algorithm and we calculate the authorities and the hubs. And then we actually show our results here. We show that our results here for mean average error, for MDCG, and for ones that have a description of shops, our HITS algorithm actually performs better than the rest of the other approaches. Okay, so that's talking about the places, the shops online on the website. And let me just bring here. Okay, so the last part here I'm going to talk about is the current work that I'm working right now, which is on recommending content. Okay, so right now I work in so I used to work in Nokia Research Center, and now I'm actually working in mobile phones. And in mobile phones, what we want to do here is that we need to connect the next billion to the internet. There's still many, many people here around the world that don't have access to internet. And how can we get them internet? Is through the phone, right? So as everybody knows, Nokia makes very cheap and expensive phones, right? So a phone like this that costs maybe like 500 RMB or less. Because these people, right, they cannot afford an iPhone, they cannot afford an Android, they cannot afford a Lumia smartphone. So that's the only phone they have. So how do they get access to the internet? So we need to do that. And we see here that there's an untapped opportunity because you see here that for developing countries, there's still lots of people that still have can get for the subscriptions, right? There's still a lot of people that don't have access to the mobile carrier. Network. So there's still a huge opportunity for people to connect to the internet. So who are those next billion people? Okay? The next billion people is not actually people like you and me. It's going to be these type of people, right? It's going to be, for example, people that are farmers. So this is an example in India, right? So people that are farmers here, people that are in villages, people that, kids, and perhaps even people that are elderly. They still want to be able to connect with their friends. Right? They don't want something that is so not easy to use, that's so difficult. You want to give them a phone, and they can easily get news. They can easily get the internet. They don't know how to use Google. They don't know how to use Baidu. Right? They don't know how to do that. So how do we do that? So that's what we're actually working in mobile phones, is that how can we deliver this internet that's smart and intelligent to those people. So that's why we want to have a phone that is affordable and appealing, and I'm sure some of you know, you have seen these phones, right? So this is phone, this is S40, this is the one I have here, the Asha phone here, and then we have the Nokia X phone here, which is this guy here, the Nokia X, which is based on Android. So we want to create a smarter internet for users in developing countries, like I said before. So I worked in the Xpress team, and we created a browser for these cheap and expensive phones, and this browser is called Xpress Browser. And with Xpress Browser, what's unique about this browser is that you can browse faster, so essentially 3 times faster, because we do compression. So when you go to a particular website, all the images, all the content or so are compressed. Because for people that stay in India or in Africa or so, they don't have a lot of money to spend. It's going to cost a lot for their data, so we want to compress the data so they can save on cost. Right? So I think a lot of times people, when they create applications and services, we take for granted we have huge bandwidth. Right? We can do this, but other people around the world do not have this huge bandwidth. So therefore, we have to make it easier for them. We have to make it cheaper for them. So I think this is where the opportunity happens here. So we created an application on top of the Xpress browser, which is called Xpress Now. And what Xpress Now does is that it helps to give you personalized web content. Okay? So let me see if I can show a quick. So this is actually coming from my phone. So this is the application that we have here. So it's called Xpress Browser. This is running on my Lumia phone here, on Windows Phone. And we can see here that when they go here, they can see, what's happening now. What are the hot things happening now? What are the stories don't miss, most watched? So we have stuff from YouTube. Obviously, I can't access it here. And Surprise Me. So this actually is content that people are seeing in India. So this is an example that we got from India. And then if we go to here, we can see what are some of the news that is hot right now. So for example, something in the Mumbai terror attacks, something here on YouTube about half-girlfriend or so, Russia, Salman Khan. So maybe someone here from India knows if this is actually hot right now or not. You can help validate for me if that's true or not. And then we have this profile where you can go ahead and you can select, what are your interests. But what we do here differently is that this content that we're getting, okay, is not coming actually, well, some of it's coming from YouTube or Twitter, but most of the content is actually crowdsourced. So we're not actually getting it from news media. We're getting it actually from people. So what we do is that we crawl all the websites that people browse using the phone. So we record that. We record all the websites, and then we have this user browsing history. And from this user browsing history, we can use machine learning to know from the web content from the URL, we can see what is that URL about. So if we see that you browse a lot of URLs about the recent World Cup in Brazil, then next time we can give you more information about World Cup in Brazil, right? So that's how we learn. And we create this user profile based on what you view, what you like, what you're doing. And that is smart because a person, let's say in India or in Africa, they're not going to go ahead and go to see their profile and I'm going to add, all these interests that they like. That takes too much time. So this is very much more intuitive. You just go ahead, browse, look at news, whatever, and then the application learns intelligently what you like, what you browse. So we use this, crowdsourcing mechanism. But of course, the issue with crowdsourcing is that there might be some particular content that should not be given to people because, perhaps you need to have someone to moderate that content. So that's one of the challenges in this. Okay, so this is also another one that we did for the mobile phone. I already showed you the one for the Lumia. So just going to explain lastly about this research that we did, and I only have 1 minute left, so I'll try to explain this quickly. So this problem here, we try to efficiently generate and improve performance of recommendations. So the recommendations, right, we have this big data. So in our case, our big data is that we get several gigabytes of web content of URLs that people are browsing from the history per minute. So how do we process that data? And how do we recommend things in real time? Because we're going to give personalized recommendation. It takes time to do personalization. So how do we make it more efficient? Okay? So what we do here is that we use a clustering-based method that's called expectation maximization method. And we compare that to previous methods. So with the personalized, with k-means, and also with EM. And we actually built one that's called efficient EM. So it's a modification of this one, but we've made it more efficient. And, right, I'll skip that one here. So this is our particular method. So what we do here is that we take the URL people's browse history, we extract the story text. So what's this actually story about? We use LDA to try to find a hidden topics. Then for each URL, we have a topic distribution. So for example, maybe this particular URL is 10% talking about sports or 50% talking about cricket. Then we can combine the URL topic distribution for all the URLs in their browsing history. And then now we have a user topic distribution. That's here, right? So now we have a user topic distribution. We put this into our recommendation algorithms here. We get these recommended URLs, and then we can now evaluate them and see which ones are good. Okay, so for here, how we calculate relevant URLs, we use this modified cosine similarity. In terms of time, I won't go through it. And then one of the problems here is that if you know about clustering, right? How do you choose the clusters? Because you don't want to choose all the clusters. If you choose all the clusters, you have so many selections to choose from the content. So how do you efficiently select the clusters? So that's how we did it here. How to select the number of clusters and how to select the number of items. And I'll skip that. So we use the logs from Xpress Browser. So we actually used from last year. And these are the number of users that we got from using those browser logs. And then to evaluate, we use this criteria. We use average rank, novelty, how hot the recommended item is, diversity. We want to give users have different type of recommendations, right? We don't want to give the same recommendation to different users all the time. So we want to give things more unique, more personalized. And then we also measure the performance as well. Right, so I'll skip that. And if we look at the results here, we can see that for average rank, in terms of how it is ranked with other particular URLs, we see here that the rank here actually, in red here, personalized actually gives you the most accuracy. Okay, you can't perform better than personalized. But for novelty, how novel it is, EM actually is better, but for diversity, personalized is. But if you compare to the performance here, k-means, if you know k-means clustering, k-means performs the best. It's very, very fast. And then the other ones, personalized, actually takes a long amount of time. So we don't want this. Even though this is very accurate, we don't want this. It takes too long. But if you look at our efficient EM, we've done it such that it's pretty close to k-means. I think it's not going to be able to beat k-means, but at least we have this trade-off that the performance is quite good as well as the accuracy. Okay, so I'm pretty much running out of time. So basically, in conclusion, what I want you to get out of my talk here is that, first of all, that mobile social networking, I think, is the next wave of social networking. So James talked about yesterday in the panel regarding about what are some of the challenges, opportunities of social computing. I think this mobile social networking, if not, has already started. Context improves recommendations. I presented a novel frame recommendation algorithm that uses proximity homophily. Presented a recommendation of shops and followers, and also how we can extend that to recommendation of web content. And how we can do this for the future, we can think about how we can recommend not just web content, but we can recommend advertisements based on the content that I like, view, and share from my phone, recommendation of particular products, perhaps phone apps, and also mobile games. So it's interesting. So actually in this conference, I met this guy. I actually know him because he's my co-editor of this book that we co-edited together. So this mobile social networking book. So if you want to have a look at this. And actually in the conference, there's a 20% discount on this book. Everybody of you have a flyer here, so you can go to the website, and if you want to order, you can do so. And what's interesting is that because I didn't actually know he actually came to the conference, he never told me. He was actually meeting another Tsinghua professor, and we just bumped to each other and encountered. So there you go, right? Mobile social networking. Anyway, so the book. You can have a look at it afterwards or during the conference as well. Another thing as well too is that I and James Shou, we are guest editors. You've probably also seen as well the flyer here for ACM transactions. So we also have a call there for smartphone-based interactive technology systems and applications. So you're very welcome to also submit a paper there. And we also have a workshop in Hong Kong. So if you want to go to Hong Kong in December, which is great, we are also organizing a workshop on phone computing. So you're also welcome to submit papers to PhoneCom. Okay, so that's me. That's my contact information if you want to connect from offline to online. And with that, I'll stop and ask for any questions. Thank you.
Is there any question from the floor? Anyone?
Hi, Alvin. This is Chewy. This is truly a great talk. I really like all of the content you are presenting. So I do see a lot of overlaps between your research and our research group. But I think you do have some advantage over us because you are from industry and you have the real product. So I'm just wondering, because nowadays there is something that when people build a mobile social network, they want to evaluate the effect of some, for example, some pages or some strategies. So they will run some, for example, randomized experiment, like A/B test. Simply put. Okay, so I'm not sure if you are aware of, like Facebook recently has this Pinot open source library that you can easily use to run A/B test to evaluate the effect of any strategy that you want to implement and evaluate. So the first question is this, and the second question will be, I'm very interested in your presentation on the mobile innovation in the developing country, because as the article in the Harvard Business Review said that the next disruptive innovation will be coming from Africa, and such as the M-Pesa, if you are aware of. So I'm just also wondering if what is the role of Microsoft? What kind of product that you expect to provide that can adapt this need? Yeah, thanks. Yeah.
Okay, so your first question was regarding about A/B testing, right?
Yeah.
Yeah. So actually for the Express, the web content, we actually do some A/B testing. So we actually have, we select a certain bunch of users and we try different recommendation algorithms, right? And we try to see, or different types of trending content, and see, if they select more or they actually like more than others. So we do that. We do this A to B. But I guess one of the problems with A to B is that you have to select the right types of users, right? In order to do this, A to B testing, and sometimes it's so that it takes time to set up this A to B testing environment. At least in our case, because we have about at least 10 million users or so that are using Xpress Browser. Actually, 100 million users now. How you have to segment them properly, and of course you don't want to break their user experience, right? So if you do A/B testing, for example, let's say in a lab environment, of course that's easy to do, right? But if you're doing it for in the wild or so, you have to choose things carefully, right? You don't want to screw up other users that are trying to use the B system, and you find out that it doesn't work. So that's a challenge for A to B testing. So I don't know if that answers that part or not. And then the second question was about the
mobile innovation.
Mobile innovation, right. And Microsoft's role, right? So after I joined Microsoft, from what I hear is that Microsoft doesn't really have too much of a big presence in developing countries. I don't know, maybe someone here can help to validate that or so, but that's what I hear is that there's really not much. Microsoft is mostly in developed countries, right, with Office products and whatever like that, but not very, very much in terms of developing countries. So hence, that was one of the reasons why Microsoft kind of wanted to buy Nokia, because of that. Nokia has a huge amount of experience in developing countries, right? So a lot of developing countries, still use somewhat, Nokia phones. There are some countries that still have a dominance of Nokia phones, and so, Microsoft knows that Nokia understands those customers, understands those requirements. There's an example in Nokia Research Center when I was with them. We had a lab in Africa, in Nairobi, and what we did is that we actually developed on a phone for artists. So artists was able to actually share their music with other people, peer-to-peer, their phone, and depending on how they shared it, the artist will still be able to get a part of the transaction cost. Right? So that was some type of innovation that we kind of built around that. So we did a lot of mobile innovation in Nokia Research Center. That was like a while ago or so, but yeah. So I think that there still needs to be more into that. I think, like I said before, I think a lot of companies or so, they only kind of focus on just the users in developed countries. Because those are the cash cows, right? Those are the ones that can afford the money, those are the ones that have the most number of people that will use the application. But I think there's a lot of huge opportunity for, developing countries because they still don't have, access to the internet and like you said, mobile innovation or so, how we can do that. So, I welcome your comments, if anything, how you can help or whatever, or collaborations, that would be great. Yeah, thank you.
Any other questions, anyone? I have one.
Okay, good.
In your navigation system, do you foresee the use of biosignals as a possible input? For example, take for example, we were looking at posters the other day.
Right.
Let's say we have a biosignals and people get excited about a poster.
Yeah.
Maybe you can find a group of friends who are equally excited about it.
Yeah. Yeah, definitely. I think so. I think this is just the beginning. So what we did here is very, very simple. It's just using just Wi-Fi. So I'll talk a little bit about the encounter. So the encounter system, right, is just very simple. So we actually use this Wi-Fi. So we know we build a positioning system, right? So we use a third-party server. So which based on Wi-Fi can actually translate to where you are on the map. And then on this map, we can see other people on the map. We can calculate the distance between the two of you. And if your distance is within, let's say, for example, 5 meters, and we can see how long you stayed there. And let's say we can see, let's say you're here, I'm here, and then we walk together or so, and then I see that we actually go away, then I know that we actually kind of encountered, right? So we have this movement that's what to capture. So, but that's what Wi-Fi. You can think of how you can do it more granular. You can have Bluetooth, right? You can Bluetooth peer-to-peer, then you can actually really see that. So I think these proximity, you're beginning to see right now a lot of indoor locationing systems, right? I think there was one example in IKEA, they built something with Google where Google built something where you can track where you are in IKEA and then recommend particular stuff that you like about IKEA wherever you are in the store. So this indoor positioning system is out there right now. But I think we haven't gotten to the point where how we can use that to actually help with this social, because social happens a lot indoors, right? Not real much, outdoors. So how do we capture that indoors? So I think that's something that still needs to be developed.
Yes.
Thank you. So I think one of the power of mobile services to model kind of the hyper-local community where people are connected online and also offline. So they, especially in developing countries, those people, they might live together and also share the same phone. And so in your experience, do you have ever modeled this hyper-local community and their behavior? And how does that this kind of modeling differ from modeling individual behavior? Do you have any?
Right, so actually I didn't present it here because I had other stuff to present, but actually there is a paper we presented that actually looked into trying to find particular communities within the encounter. So the whole idea here was that, could we find a community of all AI researchers together kind of thing, for example, right? Or can we find a community of all these people that are very much similar to each other? So we try to find, because if you find a small community like that, then that forms a social network, right? So We did that actually in a previous kind of paper, and we actually did also another paper where, based on, let's say, your location and your encounters in the morning, we can actually predict where you're going to go in the afternoon. So we actually had a paper, about 2 years ago we had a paper that showed how we can do prediction of location, what particular locations in the conference you will go to based upon what you did before. So, and I think, there's lots of research now in doing this prediction and prediction of behavior, right? Prediction of, activities, things like that, right? So it's not just only about prediction of where you're going to go, but what are you going to do, right? Activities, information as well. So, that's it. I think about.
Any other questions from the floor? If that's the case, I think I'm in for a very interesting, very engaging talk, right? And if you buy the book, don't forget to get into autography. Thank you.
Okay, thank you.
And here's a token of appreciation.